Hello, YouTube. Okay, so we're wondering what dark matter is, we're wondering what dark energy is. So I'm thinking dark energy is like, or if not, the plasma, the dark plasma. So at the beginning of the universe, we cannot pass through a certain thing because there's a plasma that's opaque, and then it becomes less opaque and you can see the background radiation, the cosmic background radiation. So beyond that you cannot see because there's a plasma that's opaque and doesn't let light pass, okay? That plasma looks like it happened a long time ago, and now it's not here. But it is here, just on another planetary scale, okay? Just, that really small level. And underneath this is the quantum fluctuation. The quantum fluctuation has a huge amount of power in it, okay? And the number that it came with, by theory, is accurate. It is totally billion million. It has so many zeros. And they're thinking, oh wow, that could not be true. But it is. It is true, but it's not radiating directly. It's being absorbed by the plasma, okay, the dark plasma. And only some managed to get through and create the universe that we see now. Today, okay, this is happening today, right now, as we speak. Alright, so that's that. For dark matter, okay? And yeah, I just would like people to find that, that's really awesome. For dark energy. So dark energy is the quantum fluctuation. How would I describe it? Okay, so quantum fluctuation. At large scale, people think it evens out and it's all like, but it's not. Quantum fluctuation at large scale also fluctuates. And it creates then imbalance and flow. And that flow is called gravity, okay? There's preference to go in one direction and the other. And so the vertical particles, instead of totally all the time getting back together, one is more pulled to one direction, one is more pulled to the other direction. That's what I'm thinking. And what's his Stephen Hawking and his Hawking radiation, okay, which is not the radiation of the black hole, but the radiation of the quantum fluctuation. All right, and it being polarized is being stretched. Okay, so we get that. So what was going on is that you have regions that are moving more, or that oscillates more than other regions. So there is a pseudoscience thing that's semantic or something like that. So it's vibrating plates, and you put sand on it or couscous, and it produces pattern. Okay, the idea is where it's vibrating a lot with large amplitude, all of the couscous grain will be pushed away and go to a place where there is less movement, okay? The plates are less moving. That's what's going on at the Planck scale, and then at higher scale also, is that things are being pulled or pushed. There's that slope, but it's not a slope just like this, it's sloping this way and that way because it's a vibration. When you have matter on it, it pinches that vibration, and so then it's kind of held there, okay? But if the vibration comes from this direction, it's like a battle rope, okay? With the battle rope, you're like wiggling it like that, and you can push an object this way. That's what I think. It should work. It should work. You just wiggle it. And, well, because it's three-dimensional, okay? And so it's a little bit different than just the simple battle rope. But yeah, pretty much you get the idea. This tremendous force and the object can totally move. Okay, let's go. So that movement creates the flow that we see in the filaments, the cosmic web. Okay, but the good news is there is no limit to how much that cosmic web can flow like this because it's already always being replenished by places that has less matter and therefore more vibration. Okay, bigger amplitude of vibration. So that's how I would think about it. These pinched places, very high intensity, like moving like tiny time, and then the other one is very long. Uh, we get that. Yeah, and I just found some scientists